you know, I was asked to really correlate it to um, um, carbon sequestration and how basically, uh, the forestry sector as a whole and tree improvement in particular going to contribute towards environmental factors in terms of maintaining those carbon sequestration cycles or climate change cycles appropriately. you know we have been knowing it very well that a tree absorbs so much of carbon and it absorbs and stores it for a long time. So it's simple philosophy, a philosophy which does not require much of the knowledge. A tree which grows short, with a lower speed or slow speed would not be that much useful in terms of sequestering higher carbon dioxide in comparison to those trees which sequester more. And this gives me drives me rather to another simple philosophy which Dr. Sivani would also be knowing. I always say that this Earth planet is has got limited area. We all know the area is limited. Now it's up to us whether we grow more trees of poor quality on larger areas or we grow lesser trees with higher qualities, lesser number of trees with higher qualities, manage them properly, use them properly. I feel there's a scientific study which says that 90% of again I'm using this example which is very classical example. In a population, it is the 10% of those higher productive individuals which carry with them those 90% non-productive individuals. So if you can take the performance of those 10% individuals which contributes to about 90% and this 90% contribute to only 10%, so it's up to you whether using the genetics tool, using the breeding tools, using other tree improvement program, you want to have a population which is as good as that of 90% of the total population of today, which contributes to about, 10% of the population today, which contributes to about 90% of the biomass, or you want a population which contributes only 10%. I would go for the first option where you would like to have only limited number of trees, good growing trees which can contribute to a substantial higher levels. So agroforestry for that matter is one such aspect which really gives you a different picture altogether and has potential to really reduce carbon dioxide to a substantial level. Agroforestry, when we say this, agroforestry is nothing but growing trees with other systems of agriculture, horticulture, animal husbandry, fisheries, so on and so forth. So when you can plug into these aspects together with good tree improvement program, I feel the net genetic gain would be going to higher, very substantially high, but it is also going to have a direct impact on the carbon basically sequestered using those genetic trees. And one more factor I feel this is somehow was coming to me very recently. When you say genetically modified organisms whereby you change the at a molecular level you change genetic composition of an individual, we have very restricted issues with this in India. We are not due to some or other reasons, more of political reason than of scientific reasons, we are not for genetically modified organisms because we say that they are going to have an impact on our health. But I feel this is one area, trees, which are used for various purposes, and majority of times they are used for long-term investments of carbon, maybe in terms of furniture, in terms of many other things. I feel if GMOs could be developed in forestry, they would have no adverse impact on the environment or on the health of an individual. So this is potentially one of such areas where one could think of having GMOs. Let's come one by one. Uh, Provenance trial, as I said, these provenance trials, as I explained, depend on the environmental conditions. We have conducted such trials in many of the species. Uh, but unfortunately, due to some or other reason, either scientific or political or something other, which I feel is not correct to discuss here, we have discontinued with this, which I feel is a very, 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 very serious issue. And we need to really continue with the provenance trials. Unless these issues of provenance trials go, unless these provenance trials keep performing very well in our, forest for genetic improvement, perhaps our road ahead will not be that smoother. If I can give you an example of Malina arborea, Lauridsen in 1966 had conducted an all India coordinated provenance trial in about 37 or 38 countries, and he concluded his results after some time, and he found three provenances from India had been doing very well across. One was from South India, another was from Central India, precisely from Orissa, and one was from Northeast. It basically it was Karshiong province, which consisted part of West Bengal and Northeast in India, Baksa Tiger Reserve, and this one, and then up to Meghalaya and Nagaland. So this was one provenance which were doing very well. These provenances, out of these provenances, Costa Rica changed whole perception of wood production. And today, Costa Rica depends so much on Malina arborea. Today, like we in India, we either depend on Casuarina equisetifolia or eucalyptus or popular. Costa Rica depends basically on uh, uh, Malina arborea. So this is the power of Provenance trial. This gives you so much of energy. This gives you so much of diversity in terms of genetic diversity that you can play on and develop long-term programs from a single provenance, because each seed of each of the family is a divergent population by its own. So once you start playing at a micro level, it changes to a big deal. Then progeny trials, as I said, you have to essentially collect seed from those plus trees, grow them individually, put them in the trial, and then see their performance individual by individual, progeny by progeny, and that gives you so much of information that you really feel thrilled. And I have given a theoretical aspect earlier. Let's take few examples of variability, how it matters. This is all these five photographs. If you could see, all these five photographs are Melena arborea. And to begin with, you see at this flower, this is completely yellow flowers. Beautiful flower. Come to second flower, you could see by yourself. It's a brownish, a combination of little yellow and more of brown. Come here, is almost equal of yellow and brown. Come here, you find a different flower color, and you find different flower color here. So when you see these flower colors, to you don't look very big. They are not very big deals. They are flowers, therefore they have to be of different colors. But if you are a breeder, you would look from them from a different point of view. These are the factors you would note. You will, scale them, and once you scale them, you note them, they are going to be useful in your breeding program. Let's go one slide up. Once, see, these smaller things do nothing, but what I have done here, next slide, I have taken this photograph and I have taken this photograph. Here it looks like the flower intensity was not more, but they were equally flowered. So I have taken these to next slide, and you could just see the color of flower. We thought there has not much, deal, but if you look at the color of the flower and seed setting, you could just see what the number of seeds set here and what the number of seeds set here. And this was invariably whatever number of genotypes was having this type of flower was very good, very good seed bearers. But in this case, they were very poor seed bearers. You could just see this. Now let's take next one. See, this is small difference. This is very, 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 very small difference. You find here the fruits are of peach type, where I'm not required to explain. They are, very, tapering kind of ends. You just see very sharp ends. They are very small, pear kind of fruits. You have oblong, you have round flower fruits, you have tapering and long-ended fruits. But if when you see their impact in real population, they have got a role to play. They have got a bigger role to play. Now let's. This I was talking about external factors. Let's take now some internal factors in case of wood. There are three factors I have just talking about here. Is specific gravity. You take wood of different genotypes. You could just see how the specific gravity of different woods of a single species of Melena. I'm sorry, Melia dubia over here. You just could see it has been varying so much. The mean is about 0.39, but it has been varying so much. Then same is the case. Progeny wise, it is differing so much. The shrinkage, the permeability. These are the factors. Those are some of those external factors I have spoken, where color of the flower, the fruit size, the fruit shape, and the inflorescence type of thing. They are external, factors. These are internal factors which are established or analyzed once you harvest the wood, you destroy a tree and analyze it. That's a kind of a variation you find, and therefore your endeavor should basically be analyzing these factors without destroying the trees. But both these parameters are essentially required to exactly know what exactly is the total status of the variability or diversity of a species has totally been. Now look at another species I'm talking about, neem. Look at the seed color, seed shape. This is basically fruits of neem. You could just see. Now I have depulped them. After depulping, the kind of variability in seeds you find, you have very long seeds, you have little thicker seeds, you have different kind of seeds available with you. And this we have done this study, we have done right from north to south, east to west, and we found so much of variability exists in neem, that is Ajagrata indica. And again I would say perhaps this extent of variability would have not been possible had I been working with an exotics. Since I'm working with indigenous crops, I'm finding such a high degree of variability available with me. Let's go one step ahead. My dear friends, you must be knowing neem today is a very very important crop. Important crop not because it's neem. You can have toothpaste of it. You can have some insecticides, some pesticides of it. You can have so many other parameters. You can have neem soaps. You can have what you call neem cake and things like that, which is insect free and which control many diseases, uh, which boost your immunity as well. I'm not talking from that point of view. This is one piece of information I thought I would put before you, and that is today neem is a commercial crop. Commercial crop through a government notification, a simple notification, and 2014 came from Government of India. It said the neem entire urea in our country has to be neem coated, and this one single notification has changed whole perception. Because when we say neem coated urea, doesn't mean that you will take the leaves, you'll grind them, you'll make an extract of it and throw it on the urea before it forms the granules. No, that is not the case. And it is not mixing of neem with the urea, it is neem coated. So we'll have to make a coat on every single granule of urea. And when we say that, we mean it's oil which is used for making such a thin layer. You can ask me what the benefits it has got, that I can explain in detail. But then you have neem oil that is sprayed when urea is manufactured, and in the factory it's sprayed in such a way that all the granules are equally coated with this one. Then once this notification came, industry was little rushy to it, and then they started diluting, because the neem oil was not available into that huge quantities, and therefore they started diluting it. In 1918, sorry, 2018 or 2019, I feel 2018 it was, another notification came. Yeah, it was 2018. Another notification came. There were some amendments, and the final one says that neem coated urea means the spray you do on urea would necessarily have minimum of 30 ppm of azadirachtin. So now another factor has been inserted into it, and that factor is that you will have to have neem oil, which should be diluted not more than to the extent that you maintain the content of aja by 30 ppm. Now that becomes a big challenge. How do you have neem which produces more oil, as well as maintains high aja content, azadirachtin content? Because in neem, that bitter content, when you chew the leaves or you find little bitterness, it is because of aja content, and that is what is more important. Neem oil, neem leaves, neem bark has nothing to do anything. It's as simple as that of any other tree, but it is that azadirachtin content that matters. And when we started analyzing that, these are few of those bottles I have put here, and these each one of them contain neem oil from different genotypes. You would say some of them are still in liquid form, some of them are still in liquid form, some of them have I would say semi-liquid, and somehow some have become totally solid. This one, and you could just see the solid crystals. Here is semi liquid. And when we started analyzing it, we found that so much of variability exists. And again, I would say, had I been working on an exotic, perhaps I would have not found that kind of variability. The classical example is that of Jatropha. Jatropha failed. Somebody might argue it has not, but I say it has failed across India because it was an exotic. There was no variability existing here. And if that is the case, then we are in a very bad situation. I would not go with this example, but this is another example, I would say, how tree improvement contributes. Dr. Shivani, Dr. Shivani,
Yes, sir. Yes, sir.
yeah, you will have to indicate
Sir,
me when I have to stop my presentation.
sure,
Otherwise, I don't
sir.
know. I would keep talking, and then
Sir,
your students should not feel
you
bored.
have half an hour, sir. Sir,
Still
you
half an
have
hour.
half an hour, and you want more, you can, or before that also you can, sir. Up to you, sir.
No, I have no issues. I can keep talking. Your students should not feel like caught.
No, no, sir. It's okay, sir.
Okay, and this is one classical example of tree improvement and impact of tree improvement as a whole in a society. How the society accepts it. Till date, we have been talking about 3-4 species in major. North India, if you come, we talk about poplar. Throughout country, we talk about eucalypts, and in southern parts, basically we speak about casuarinas. So these are three major commercial crops. One of them is one of the most wonderful scaffolding, that is Casuarina equisetifolia. It's a very tough wood. North India, if you come, one has changed whole perception of plywood, that is Populus deltoides, and eucalyptus is in between. It plays majority of roles in plywood, not quality plywood, rough plywood. Paper industry, it has changed whole perception as a whole, and so on and so forth. But then you have very limited options available with you. Very limited options. If you want to grow for agroforestry, either go for these three crops. If you fail there, I feel you fail everywhere. And therefore, there was a pressure that we'll have to come up with some other alternate materials. And one of such materials we started working was Melia duvia. It's a synonym to Melia composita. So when we started working upon that, these are few photographs we have taken. I feel Dr. Shivani was working with me that point of time. At that point of time, somewhere I feel 2005 or 2006, we started working this. You could just see these are pure plantation of the species. These are those plantations which are on the roadside. These are the plantations which have been put on the burns of agriculture crops in Punjab. We know Punjab is one of the um, heavily agriculture dominated species, dominated state, and they are also fond of agroforestry, particularly on burns and all that. So just you could see the quality, and then these are irrigated pure plantations. So these are four type of photographs we found, and we started working on this. So when we started working on this, look at this. This is the condition where we started under unimproved plantation, which I have shown in the previous slide, and these are those irrigated or burnt plantations. Now we started working upon that, and the result is that today you have a plantations like this. And if I go with individual tree, you could see the kind of straight board you have got. You could just see what the kind of clear board you have got. And now look at those plantations. These are few plantations which have been established after selecting those materials, bringing them to a platform, putting them in different environmental conditions, putting them in different environmental conditions that called G into E, genotype into environmental interactions. These are the conditions. These are the trials give us a clear indication how a particular genotype, what the worth of genetic worth, what the genetic worth of an individual has been. And if you look at look at these four, this is a photograph from one of our trials, which is established in Uttar Pradesh. This is another trial, and in Punjab. This is a trial which we have put in Uttarakhand, and this is from Haryana. So this is same one single genetic material, one set of genotypic materials of about 20-25 genotypes. We have put across different regions, and you could see their performance. At micro level, there could be many factors, but at least at one factor, you could just see what kind of straight bowl, what kind of diameter it is maintaining. And then if you go further, that's how you find stability. There would not be any doubt that there will be some genotypes which would be stable. There would be some genotypes which will be interacting with the environment much more than otherwise, and there will be some genotypes which will be coolly playing their own roles. So if you look at them, see, if I can just put this whole set of genotypes into this graph, you could just see that this is how it comes. So this is, if you take in the previous slide when I was showing the theoretical slide, there was one model which called Eberhard and Russell's model. It says when your regression is zero, that genotype is considered to be most stable genotype. So I'm sorry, when regression is one, then this is called most stable genotypes. So these are the genotypes which have fallen on this dotted black line, which are stable. But then you'll have to find out these are stable, but are they productive or not? So we have gone for these genotypes which are productive, but these are the genotypes which are not productive. These are the genotypes which are on the upper circle. They are very, very productive, but they are not stable. Their performance is bound to change with change in environment. It is something like this. A student with ex-teacher does well, but he is highly, highly susceptible with the teacher, and the moment the teacher resigns, his performance or her performance comes down. So these are those genotypes. They are very, very vulnerable section. These are very bright students, but if you don't get a good teacher, these students are not going to do well. Same is the case with any of the biological material. Genotypically, they are very good, but they are good as long as they are in a good environmental condition. So this plays a very big role. So when I said this theoretically, perhaps you people would have not thought that it's practically also possible. But here I am giving an example which Dr. Shivani has been part of this analysis, has been part of this program, and we have done it in a very collaborative manner.